Hello, dear students. Let us see what is meant by strict schedule. Now, in the previous video, we were learning about cascadeless schedules, correct? And the example that your teacher gave is as shown below, where there are three transactions T1, T2, T3 running concurrently, correct? And the data item A, which was updated by T1, this data item A, which was updated by T1, is actually read. This data item A is read by T2. But this A, which is read by T2, was updated by T1. Now, what we said is, for this particular schedule to be, first of all, cascadeless, what should be done is that T1 must commit. T1 must commit, and only then after T1 commits, only after that read instruction can be executed by T2. This is what we said. Now, such schedules where there is a restriction or there is a rule imposed that the data item updated by T1, if it is supposed to be read by T2 or some other transaction, then T1 must commit first. You can see, and after that, after commit, T2 can read the data item. Such schedules are known as strict schedules. Just observe the sentence I am making here. Strict schedules are cascadeless schedules, because this was cascadeless schedule, isn't it? So whenever you say that schedule is strict, what does it mean? That a value updated by transaction Ti cannot be read by transaction Tj until transaction Ti commits. But what if you just think of this? What if this commit, which I am striking away, was not written immediately before read of T2? It was not written before this, but it was written somewhere here. I'll write C in short, commit. It was written here, okay? And the commit of T2, which I am striking out now, was written after the commit of T1, somewhere here, after the commit of T1. And similarly, commit of T3, which I am striking away here, was written somewhere after the commit of T2. Then this schedule is cascadeless. Please try to understand. This schedule is still cascadeless, but it is not strict. So what is the difference? Is that if Tj reads updated value of Ti, then Ti must commit first, whether it is immediately or whether it is later. But Ti must commit first, and after that Tj must commit. If that's happening, then the schedule is called as cascadeless. Whereas if we put a rule like this, if we impose a rule, the rule is that before this Tj reads a data item A, which was updated, just check this was updated by Ti or T1, before it reads, the commit must be executed by Ti. Only after that Tj can read. Similarly, you watch, here is the updation of data item A done by T2, and this data item A is getting read by T3. Now T3 won't be allowed to read the data item A unless the commit occurs in the transaction T2. So this type of schedule is known as strict schedule. So what did you understand is, writing in short, if you have a strict schedule, let's say I am writing in short S, okay? Imagine there is a strict schedule. Then Is this strict schedule cascadeless? Indeed it is, isn't it? Because here there won't be any cascading aborts. So every strict schedule, if you think of a set, just imagine a set, okay? I'm drawing a Venn diagram. Just imagine a set. This is set of strict schedules, and this is a set of cascadeless schedules. I'll write in short as C. Then, if you think of all the cascadeless schedules, imagine, and if you think of all the strict schedules, you can see every strict schedule is cascadeless. But obviously, vice versa is not true, because if you remove commit from here and you write it here, let's say at the bottom, if you remove commit from here and you write it here at the bottom, and this commit also you write it somewhere down below, then this is cascadeless. But the strictness which we had imposed, that before even reading the data item A, which was updated by T1, T1 must commit. Before even reading the data item A by T3, which T2 had updated, T2 must commit. These rules are not followed, but still it is cascadeless. I hope you have understood difference between cascadeless schedule and strict schedule. Thank you very much.